if I told you that you have an angle formed here, again, it'll always be initial side, the positive x-axis. And let's say it passes through this point 3, 2. Okay, so here is the angle that we're talking about. And I asked you to identify all 6 trig ratios of this angle. Any ideas on how we could go about doing this? Okay, so one suggestion is make a triangle where? From this point. All right, so if we make a triangle from this given point straight down to the x-axis, okay, how is that going to lead us to figure out the ratios? You are right. Good job. Okay, so what is this length here? 3, because that's the x-coordinate. What's this length here? 2, that's the y-coordinate. And so how can we find this distance along the hypotenuse? Pythagorean theorem. So what we could do right here is we could say that this is the square root of the sum of the squares of the other two sides, right? So square root of, square of 3 is 9, square of 2 is 4, 9 plus 4 is 13. So again, if you needed to write it out, you have 2 squared plus 3 squared equals, okay, I'm going to call this r squared, or r, since if we had created a circle here, that would be the measure of the radius. Okay, and so 4 plus 9 is equal to r squared, square root that, root 13 is this length. Okay, now, how is that going to help us? What is the sine ratio then at this angle? Opposite. 2 over root 13, which can be rationalized into 2 root 13 over 13. Okay, the cosine is 3 over root 13, which again, rationalized is 3 root 13 over 13. The tangent is 2 opposite over adjacent, 2/3. And then you can do all the reciprocal functions here just by inverting. And again, that's why I wrote this form for these two. Just take root 13 over 2, root 13 over 3, and the cotangent 3 over 2. Okay, now, when you look at this, just in a general sense, okay, let's look at what we have here. This value is a radius. This length right here is your y-coordinate. This length right here was our x-coordinate. And so if we were to put these ratios just in terms of x, y, and r, which is what your book does, okay, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. The tangent is opposite over adjacent. And then each of these reciprocal functions, again, r over y, r over x, and x over y. So your book actually gives you these forms. I wanted you to see where they came from before you're given those forms. Because in my opinion, it's just easier to create the picture anyway than to try to remember what all of these, or first try to remember what these equations are, second try to remember what they stand for. So you're welcome to do it either way. We can also look here to see this relationship, x squared plus, or in this case, y squared plus x squared equals r squared, which means r is equal to the square root of x squared plus y squared. So again, you can use these pieces of information in red to help, but easiest thing is just to draw the picture and recreate it from that.